Hello folks, and welcome to another edition of Physics Online, where today we're going to find out how to subtract vectors. But before we do that, let's do a little bit of review. Fill in the blanks for these two steps for vector addition, and then see if you can solve this problem which we apply those two rules. We imagine we're traveling by plane at 300 meters per second due east. Suppose there is a constant headwind of 20 meters per second. In other words, we're heading into the wind, and as you might suspect, the plane will be slowing down. What is the resultant velocity of the plane relative to the Earth? We can find our answer by adding the two vectors geometrically. We're going to let v sub p be the velocity of the plane, and it's going east, and v sub w the velocity of the wind, but it's going west. So our vector equation becomes v sub r equals v sub p plus v sub w. So in this space right in here, draw the vector diagrams and come up with the resultant. Push that pause button and then we'll come back and compare answers. All right, let's compare some answers. We add vectors by connecting the tail of one vector to the head of another. To find the vector sum of the resultant vector, you connect the tail of the first vector to the head of the last vector. In this particular problem here, we first had to draw the velocity of the plane vector. It was going due east, but then the wind was blowing in the opposite direction. So that vector, v sub w, is going the opposite direction. But notice we're connecting the tail to the head. To get my resultant, I go back to the tail of my first vector, which was the plane, and then I connect that all the way to the head of the last vector, and we get the resultant being 280 meters per second. Now let's take a look at vector subtraction. First of all, we need to take a look at what a negative vector is. A negative vector, negative v, is a vector whose magnitude is the same as vector v, but it points in the opposite direction of v. So here we have a velocity vector v shown going in this particular direction, this particular magnitude. In this space right in here, what I want you to do is draw the velocity vector negative v. Push that pause button and draw it right in this space right there. And this should be your result. Notice it has the same relative length as this one over here, but it's going in the opposite direction. So that's what we mean by a negative vector. Same magnitude going in the opposite direction. Here's another problem. Suppose we have a velocity vector, v sub 1, going 2 meters per second north, and then another velocity vector, 2 meters per second east. And what we want to do is subtract these two vectors to find our resultant. Our velocity, our vector equation becomes v sub r equals v sub 1 minus v sub 2. And note that subtracting vectors is the same as adding a negative. That is, the resultant equals v1 plus the negative of v2. And thus we can use our rules for vector addition. In other words, we're simply adding two vectors, but one of them you're going to have to change the direction. So using this reference system right here, draw in the vectors, add them geometrically, show the calculations to find the resultant. You'll need to find not only the magnitude, but also the direction. So push that pause button, and then we'll compare answers. All right. Let's take a look at what we have here. First of all, here's v sub 1. There's the velocity vector going north. But then it said we have a velocity vector going east. But we're subtracting the two vectors, so we're going to have to think about the opposite of east, which is obviously going west. So here is v sub 2. So we've added these two vectors by adding a negative. And now to get the resultant, we go back to the tail of the first one and draw it to the head of the last one. So here's our resultant. To calculate our resultant, we can use the Pythagorean theorem, and notice we have the magnitude of our resultant, which is 3.6 meters per second. And then we need to get the direction, so we need to find the angle. We find that to be 56 degrees north of west. Again, if we went due north, go this way, but we want to get on our vector, so we've got to go toward the west. So the resultant velocity vector, that is subtracting these two vectors, will give us 3.6 meters per second, 56 degrees north of west. And we are through with that particular problem. Boom. Now that we know how to subtract vectors, here's some particular practice problems. And notice I've given you the answers in parentheses. So show all the work in your supplement. And if we scroll down here a little bit, here's a couple more problems. Again, the answers are in parentheses. So I thank you for tuning in, and have a good day.